everyone. And we will be talking about standards and the strategies. And as you know, standards are key to everything in the communications. So it's hard to live without standards. So maybe they not key anymore. So what we're going to do very quickly, we'll introduce ourselves, and then we'll. I have lots of questions, but it's really a session for you. So anyone in the audience is more than welcome to ask questions. Let me start with myself. I'm Anatoli Levine. I work for a company called Spired Communications. We provide testing tools for the communication industry, and we also build products for IoT developers. I also happen to chair at the moment a consortium, which is called International Multimedia Telecommunications Consortium, which is starting to do a little bit of work in the IoT space, but primarily known. We've been around for more than 20 years, and it's a consortium which was working on the interoperability issues of all the multimedia communication technologies. So we have a lot of experience with that. So now, Stacy, can you?
Hi, everyone. Thanks for coming. My name is Stacy Kennedy. I work for Cisco Systems. I'm here representing the Trusted Computing Group, an open standards body that Cisco holds a position in. They are actually on the board of directors for the Trusted Computing Group, and I am their board representative. The purpose of the Trusted Computing Group is to write standards that make it possible for machines to make informed decisions about what other machines they will talk to and why.
All right, thank you. Matt?
Hello, everybody. Can we go? Hello?
It takes 2 seconds.
Hello, everybody. My name is Matt Lear. I work for a company called iConnective. You may know the company. It was formerly called Telcordia, and before that, Bell Communications Research. The company itself is focused on interconnecting as a trusted, neutral provider of registries and directories in the telecom space. And I'm here representing 1M2M, which is a global standard being developed to do M2M and IoT and middleware services to allow for interoperability across different technologies and different business verticals.
Thank you. Christian?
Hello, hold on a second. Okay, it works. Hi, my name is Christian Lagari. I'm the CTO of Micrium, and I'm also the chairman and president of the IPSO Alliance. So I have a different tack on standards. The IPSO Alliance is not a standard definition organization. So we are not publishing standards, but we are using the standards. And that's the thing. So at IPSO, what we do, we publishes best practices and guidelines. So IPSO was created in 2008 to promote the use of IP. So IP in our acronym IPSO, Internet Protocol, and smart objects. So the Internet Protocol and the things in the IoT. Last year, we rechartered IPSO to say, okay, the industry understands that we need to use IP now in whatever device we're going to manufacture. But the thing is, the question we have from our community and our members is, how do I use IP? And the how, of course, comes a lot with the standards that exist today or will exist. And what IPSO is doing is putting all these things together in best practices and guidelines. So this is who I am, and this is what we do.
Thank you very much. Okay, Joaquin?
Good morning. My name is Joaquin Prado from Open Mobile Alliance. My role in OMA is technical director. And Open Mobile Alliance is something that most of you probably know our products like MMS, multimedia messaging, device management, location-based services. And at the same time now in the IoT space, we have a new service called Lightweight M2M. And is a protocol, device management protocol for constrained devices, which is using CoAP as a payload. So CoAP for us is transport mechanism, and we provide not only the device management for constrained devices, but we have as well a data model which can represent any sensor. And that is one of the advantages in the case of lightweight end-to-end. Normally, OMA produce specifications for the telecom industry, but device management is not necessarily a telecom protocol as such. It can be applied in other areas as well.
All right, thank you. And Donna?
Good afternoon, guys. Oh, you can hear me. My name is Donnie Assay. I work for a company called Marvell Semiconductors. For those of you who don't know what that is, it's a chipset company, and if you were to pop open a Google Fiber router or a Barbie doll's head or a wireless Roomba, the technology is in that. I represent a standards body called the Home Grid Forum, which promotes a technology called GNIHN. Unlike these gentlemen, I'm more of the layer 2 kind of technology. So we help proliferate. GNIHN actually is a chipset that can work on any wired medium, like coax, power line, POF, phone line, and we help promote and proliferate wireless as a backbone.
All right, thank you. So this is our panel. So let me start with one simple question. There've been 2 days, so with the exception of the first day, when in the first day we did talk about standards, but now think about presentations which took place on a floor and the sessions. So the interesting thing is that the IoT world is moving along happily. The people seemingly build their solutions, and people don't necessarily really concern themselves with the standards. So what is the role of the IoT standards in the IoT industry, really, in the Internet of Things, and how do you see that? And so compared to telecom does not exist without standards, but in IoT, everybody seems to be happily delivering solutions without giving much regard to the standards. So what do you think? Go ahead.
Yeah, I don't know if any one of you saw the McKinsey report last year, but McKinsey said that 40% of the value of IoT will come from interoperability. To achieve interoperability, you need to work on the same level. And to do work on the same level, you need to work on the same standards. You need to have something that I speak French. If you speak French, then we can understand. And really, I'm French Canadian, so I do speak French, okay? But if we want to have this discussion today in the panel, we need to do it in English. Then you can understand me. So standards will bring interoperability, will bring the 40% added value to IoT. Absolutely. That's one of the reasons.
Okay.
I totally concur with Christian. And the other thing is that, in my view, what we see nowadays is there is a market there. Some companies, they see, okay, let's go to position very quickly, let's go to get the customers, and let's go to propose, I will say, their own protocol, top to bottom. And they get there very quickly, but what they are doing is they lock the customer in a very proprietary solution. Then the customer eventually will say, fantastic, I have something that works. Tomorrow they buy something else. They try to plug it, they say, it doesn't work. The telecom industry has been through that already, and that is the reason why we always fall back into the standards. So interoperability is key in this case.
Okay.
I'd like to chime in here as well. I agree with both of the gentlemen here. But additionally, you have to think of some of the history too. Telecom was very highly regulated, right, which allowed for a lot of that interoperability to occur because there was a mandate. Like, you did not get on the telephone network if you didn't, conform to these certain things, based on regulatory bodies or the governments, right? IoT, it's a little bit like the Wild West and a lot like boiling the ocean. We were, talking about that before the panel started, right? You've got a lot of companies that are, MVPing, racing to put stuff out in the market. There's a lot of different business problems and verticals to approach, and you can't do everything. So folks will pick something and try and solve that particular problem, and then the issue arises, back to that McKinsey report. It's like, how do you interoperate with something outside of your vertical? There's so much value there in connecting verticals, and I think that's why, an overarching standard that'll accommodate different verticals and different technologies as well. Some of the devices are very constrained. They can't use certain standards because the devices just don't have the compute power. So that's one of the issues, that we're facing today, and why an overarching standard may never be possible.
Okay, so I'm here representing a security standards body. With regard to security, the value of standards is that well, there are a number of values. First of all, it makes interoperability secure. It makes it possible for us to communicate in a standard way that does not betray confidentiality or integrity of the information being sent across. So if I'm going to encrypt something and send it to you, if I use a proprietary encryption, just as our French-Canadian associate said, and send it to you, have I helped you at all? So in order for us to share information in a manner which does not jeopardize that information, we have to have publicly reviewed, academically reviewed, commonly understood standards based on, for security.
And I agree with all of these gentlemen on what they said. Luckily, with the organization that I represent, my security is layer 2, so you don't even see it. So one of the things, you're never going to have a unified standard. It's like different operating systems, different models of gasoline in your car. You're just never going to have everybody agree. But one of the things that you can do as a standards body, or an alliance for that matter, is to promote open APIs, open Linux stacks. Like, for example, the organization that I'm a part of, gives to the open source community to give freely to other competing standards. Because we know in the end, we all have to shake hands. And if we don't, someone's going to die. So we'd rather all, flourish and prosper together economically than not.
Okay, very good. So that essentially lead into two questions which I want to ask. I cannot ask two questions at the same time. So, and I also don't like the panel where everybody agree. We need to find something where we need some fight here. But okay, that probably not going to be a fight. But so one question is, right now there is about 140 standard defining organizations, 125 standards or so, all related to Internet of Things. So where are we going? Is there room for more? There will be more standards created before a lot of standards will die. I mean, how do you see that space evolving?
I think there's always going to be, this propensity to try and build a better mousetrap, right? So a particular standard being applied to particular technologies. Who's to say in 5 or 10 years from now there won't be some new technology that requires different standards because of the communication paradigm or the capability of the hardware or the advancements in software. I think that's a no-brainer. You're always going to have standards evolving and new standards coming into place. I think from an interoperability perspective, the standards have to be willing to work with each other. The issue really becomes in that middleware services layer. How do you communicate stuff? How does one standard describe an object semantically, what it's capable of, the data it's collecting, the security model it's using versus a different standard, and how do you reconcile that? That's where I believe a lot of the focus has to lie.
For me, I think that viable standards are standards that address the most widely held concerns that people have. USB, for example, it was difficult getting USB asserted across the industry, but it served a very fundamental need to connect computers, to transfer data. So USB addressing a widely held problem remains successful. Likewise, other standards that focus on the most widely held problems that we all experience are going to be the standards that thrive and flourish. Niche standards may survive for a period of time, but as the market evolves, they are likely to be faced with change or die.
Okay.
So to answer your question also, are there too many standards? Yes. Okay, and that's one of the reasons why the IPSO Alliance is working. We're not defining standards. We want to find the right standards for the right usage. Okay, So depending on the vertical markets, medical, industrial, consumer, transportation, there are certain specifics in these vertical markets, and some standards apply and some don't. So what the work we're going to be publishing in the following months and years are that, best practices and guidelines. How to use, which standards to use where. Will there be new standards? Absolutely there will be new standards, and I agree with Matt. Now the IPSO Alliance represents the embedded device, the thing in the IoT. Right now, if you look at most of the consortium, they're looking at the cloud and the networking, etc., the back-end stuff. The thing is that when you try to apply these IT technologies to embedded devices, it doesn't fit. You can't fit, the tool, the complete TPM or TCG, on a Cortex-M that has 200 megahertz and 64K of RAM. It doesn't fit. So what do? We need to look at it differently. So how do we link these embedded devices so that the whole chain from end to end, from the embedded device to the cloud, so there will be new standards. There are existing standards. Some will drop, and so we're trying to do a little bit of a cleanup and help the industry. That's what our members are asking us.
Okay, so now let me go back to something which where all of you started, talking about standards. So, and this is what Carl, are you around? This is what Carl Ford wanted to know. All of you guys said interoperability. So thinking about the 7 layers, right? And which layer do you think, okay, not layer 1, but at which layer are we going to achieve interoperability, or at which layer do you want to see interoperability achieved?
Yeah, at IPSO, we've started to work on interoperability at the data layer, which is above the TCP/IP stack in the CoAP, MQTT, HTTP payload. Okay, this is where we start interoperability. So we've published a standard for data model and metadata model that has started to be used by OMA, for example, and by Bluetooth. Bluetooth now has something called BIPSO, so Bluetooth IPSO, and defining the model, meta model. So this is where we're starting. But when we're going to get to security, we need to get there also, because how do you have end-to-end security if you have to go from an edge device to a gateway, and the gateway does the translation? If you open the packet and suddenly there's an attack surface right there. So how do you make it work also? How do you ensure end-to-end security? So there's right now from IPSO we're starting at the data layer, so it is above the TCP/IP stack, but then we'll have to have other interoperability at other layers.
Okay.
As Christian say, OMA works in the application layer, and for us, we develop protocols that are network agnostic. It can go through cellular networks, Bluetooth, Wi-Fi, you name it. And we, in our application, we build security as well. In the case of lightweight end-to-end, we have DTLLs as a security. So for us, in that aspect, there is being network agnostic. We say all the security in the other layers, we reduce that, and then we put our...
The question was about interoperability, not about security.
Okay. Good point. What I try to say here is the interoperability, we say where this interoperability should happen. Well, for us, we are network agnostic. We are use transport, and any other the protocols for us are transport in that aspect.
Okay.
Yeah, I think it's got to be on the application /services /data layer. In terms of network technologies, I think we've talked about it a bunch already. That depending on the device and what it's physically capable of, you're going to have different network technologies in play all the time. It's really once that thing gets into that middleware, how do those applications share and consume data or collect data, and how do you manage things like privacy and access to that data, permissions? Hey, this is the thing I'm collecting. Hey, this is what I want to use. This is what I want to see. So I think that really has to happen more on that services layer.
It's almost impossible to keep you guys in a track. I say interoperability, you say no security. No, interoperability. No, security.
But that certainly promotes interoperability, right? Like if people are building applications that don't talk to each other or don't, recognize a data
That's
model,
secure,
right?
Right?
Well, no, because you can't access that data, right? And sure, it does play into security. because now you might have a flaw. The way you're handling something is not the way somebody else is handling something. You can get man-in-the-middle attacks. You can get all sorts of things like that. So.
Okay, let's leave security for a second. Okay, so you...
We're security geeks. That's
Okay.
why you got us here.
Okay.
So what I'll say about that is there's no value to interoperability if the data that's being shared is compromised as a consequence of that interoperability. So from a geek's point of view, security geek's point of view, interoperability is bad to the extent that it creates an attack surface that leads to compromise of business value. So with that, from that perspective, the focus of the Trusted Computing Group is to make sure that there are specifications in place that create security and trust at hardware, firmware, software layers, and at as many different layers in the communication model as possible, typically layers 2 through 7.
Okay, so Donna, you layer 2, so...
There's no interoperability. What are you kidding? Just kidding.
Good.
I'm a chipset guy, okay? Fundamentally, that's why we have standards, right? You have, coming from literally, I'm the root cause, right? When it comes to issues, right, from a chipset perspective. That's why you have, for example, Broadcom or Qualcomm or Intel, all of the semiconductor guys go to standards like ITU, IEEE, so we hash out so we can all communicate. Because we all, if we don't communicate, we're not going to universally sell the end device to the consumer. So there is a certain amount that we do have to play nice. But then, like other folks say, there are those proprietary mechanisms that people like to do, where you have to have some type of advantage. But ultimately, that's why we need standards, because it helps foster that interoperability. It forces the interoperability, so you don't have that myopic view of I just want to rule the world and it's only me and my kingdom. So you have to enforce. That's the key to standards, is to enforce that interoperability.
Okay, very good. Any questions from the audience? Okay, Richard.
Standards bodies historically have been home-ported, if you will, in Europe and the United States. Do you feel that interoperability requirements of countries like China, India, Indonesia, Brazil are going to have an impact on the standard sets designed because they have not played as strongly
So TCG entirely agrees with that point of view. There are member companies on the board of directors from Asia, Europe, and North America. The membership is predominantly North American, but even Europe and Asia together outnumber the American companies in the membership for Trusted Computing Group. But you're exactly right; they have to be represented.
And at the same time, when they're going to force a country standard, which is different than other countries, they're just doing the same thing that companies are doing to each other. GM, Ford, Mercedes, BMW, they have their own system, and they don't want to interoperate. So at some point, it's going to hit them, because if you're a car rental company, you want to be able to get your car and you want to have a unique system managing all your assets. So at some point, you will have to have either the business will force it, or we'll never get to I always describe IoT as this exponential curve, right? We're always predict these billions of devices in a near future, okay? So right now we're ramping up slowly. Then there's going to be an inflection point at some point, right here. Then we go exponential. But if we don't get to that interoperability, we'll never get to that inflection point, never. So company-wise, country-wise, same problem, just a different scale. But yes, we'll have to, if we don't get it, the consumer will do something. There will be a market force driving it, I think.
Okay. Anyone in the audience gateway manufacturers? No? This sounds like a gateway heaven, right? We could rename this panel into Gateway Heaven, because that's what all this, all these individual clouds have to be connected, right? Okay, anyone has any questions? Okay, then, okay. So, I need to get you guys to disagree on something.
I can show you my hot buttons.
Which is hard with standards. But, so, the interesting trend, not trend, but the fact, whatever way we want to call it, is the role now open source is playing. It's becoming now pretty difficult to understand, like, technically chicken and the egg or whatever. What's first, standard and then implementation? Or when it comes to open source, in a lot of cases, there is boatload of code which is going into open source, and then all of a sudden we call it a standard or semi-standard ecosystem, whatever it is. So can you talk about this relationship? And in the end of the day, it does relate back to the role of the standards, but I don't want to position it as standards versus open source, but maybe that's what it is.
Yeah, I would say they're actually pretty collaborative. So in the case of like 1M2M, sure, there's commercial entities that are involved in it, heavily involved in it, and they're building commercial solutions based on that. But there's also a big open source community for that as well. Kedi, which is you consider, I guess, the ANSI of Korea, has built an implementation of the 1M2M service layer in open source. And the way I think open source can help the standard back or pay them back for that is by, they're trying things out, they're implementing this, and they're finding out what works and what doesn't and what gaps exist in the standards. And that information is invaluable. A bunch of, eggheads like us sitting in a room and saying, no, this is the way we should do it, is a lot different than somebody actually implementing something and saying, this is pretty crummy. Wouldn't it be great if we did this instead? If you use the analogy who here remembers Corba, right? So Corba was that whole interoperability for objects to be passed across the wire and share information. Enprise, Borland, all those guys, they started with standard, and then they started making extensions to that standard, and then they would lobby to get that extension into the standard. So, hey, we support Corba 1.1, but we've got this other thing that we're hoping makes it into 1.2 because it solves a problem like naming and addressing that wasn't addressed in the original standard. So I think they can be collaborative and complementary.
Well, here's your disagreement. From a security geek's point of view, you have to start with the standard. The standard has to come first. The architecture, the design, the technology evinced in the standard has to be vetted, and then code has to be written. You just slap together a bunch of code and throw it out there and call this a security solution, you are begging for it. So that's it.
Good, okay. Go ahead.
Yeah, I would like to share something. That in OMA we have we are running a program for developers, and specifically in the space of lightweight end-to-end, Eclipse Foundation, they took our standards and they developed 2 projects inside of Eclipse, Leshan and Wakayama. And we organize certain test events, and we allow that to collect fault or problem reports, bugs that the developers identify with our specifications through GitHub. And we are getting a really good feedback from the developers, specifically say, hey guys, I don't understand this particular part of the specifications, or there is something here that it doesn't make sense, or this is not very clear, and so on. So that collaboration is working quite well. But I can tell you that the biggest problem that we find the standards and the open source is in the very first milestone of what the standards is representing in most of our cases, is IPR. Our IPR policies and the open source policies are totally different. And that is where OMA, we are collaborating with Eclipse. They told us, hey guys, we have a problem here. Specifically, OMA is one of the products that we have is what we call the XML support documents, XML documents that describe objects or resources. And these objects are released to the market, but with an IPR, with a legal disclaimer, which doesn't allow the developers to take that code and incorporate it as part of their code. And they come back to us and say, can you do something about this? And it has taken a while in OMA to sync that concept that we need to change our legal disclaimer, our copyright changes. We did the changes, but it's still not all the way that what, in this case, Eclipse would like to have. So that confrontation, that problem is going to be there, and that's something for the industry to figure out how to resolve it.
So I'd like to add on also, and I agree with Stacy, I think the standard needs to come first, but open source is maybe a way of getting fast to proof of concept, doing that. But open source means that you have multiple cooks in the same kitchen, in one kitchen, okay? Now, I'll put my Micrium hat now, okay? So Micrium, we are an embedded software company. We write embedded software. We sell a real-time operating system. A lot of our customers are from the medical vertical, or from industrial, or from avionics. To give you an example, Mars Curiosity rover right now runs Micrium software.
Yes.
Okay, yes. When NASA used it, they didn't change one line of code. But the code we produce from Micrium needs to go through these certification bodies. Needs to go through IEC, FAA, FDA, etc. You can do that with open source. So open source is good. You can do a quick proof of concept and you can do that. But when you go to certain verticals, it's going to be difficult to justify the cost of certification of certain.
I'm not sure I'm allowed to disagree, but I would disagree about open source and certifications because there is FIPS certified version of the SSL, so it's not true.
No,
Open source can be certified.
But someone paid for it.
So,
anytime.
Donna, please.
I actually have to disagree with Stacy and Christian.
Yes.
I actually
Good.
don't think it's serial. I think it's actually parallel. I don't think you have to have a standard to have open source in the space that I play in. Open source is actually Switzerland because we're all adhering to a standard and if we're competing with another standard that's completely interoperable, that we actually use open source as a means to say, okay, if we all agree to this open source and then we bring it back down to the nitty-gritty of picking apart the actual standard from the open source code. So I think it's actually, it can actually play parallel versus serial.
You're going to die.
Here we go.
This reminds me of something. I would like to share this experience that we have in the case with Eclipse and us. As I mentioned, Eclipse took our specifications and they developed the source code, which is open source. They have 2 projects inside of Eclipse. And the collaboration in these 2 projects is a little bit unbalanced. Some more companies are working in one project than the other. So one of the projects is moving faster. They find problems, they send it back to OMA. OMA is taking time to resolve the issues. So the other project is moving forward, and sometimes they come across a concept that they have resolved in the first project in different way. And then they have the problem, okay, what the standard says is, well, we don't know. We have sent this request to standards. So now they have to go, and they cannot get an agreement between them. They need to refer to some kind of reference. And that reference, the developers, they will find very difficult to resolve the problem when they are doing in different language. So that is, in a way, that function of have people discussing ideas, putting some thoughts first, that is always good. If you don't do it in the standards, you will have to do it nevertheless in the open source. And the open source guys in general are guide to write code. They work in a very different faction and they find very difficult to get this type of agreements on them. I don't say they can't, but I say they find it difficult.
So it's a tough relationship. Okay. Questions from the audience? Yes, go ahead.
So I work for Intel, so yeah, we do make gateways, good business. But I also here representing the Open Connectivity Foundation, which I think some of you are aware of, some of you guys are members as well. So that is an organization, almost 200 member companies, where open source and standards work collaboratively together. So within the standard side, there is a work group, which is the open source work group, and they manage an open source project hosted under the Linux Foundation. So IPR is solved through certification, right? So if you are not a member, you can take the open source under Apache 2.0, so you get underlying IPR grants. If you are a member, you take the open source, you get your product certified, and then you get the IPR in the spec as well. So there are consortiums that are around that are doing this, and we think that it's a very good thing.
Okay, one interesting question would be, where is your reference coming from for the recertification?
From the spec.
Who implements that?
The open source working group, right? So it gets implemented in open source, but they're implementing the spec.
I love certification. We should do a panel on certification. Thank you. Any comments here? Huh?
He's spot on, yeah.
Spot on? Okay. Okay, very good. Anyone? I have lots of questions. Yeah? Okay. Okay. No, we have another 10 minutes. Yeah, it's now to 1:10, starting at 25. So now I want to actually officially go back to the subject where you all tried to pull into, and Stacy did not pay me, but I want to talk about security. So how every standard is doing their own thing on the security, how we can, and again, it's now we from security don't jump back to interoperability, but we can't avoid connecting the two. So how are we gonna get somewhere with every standard having its own security considerations? We want to end-to-end solutions, right? So so how are we gonna go about that?
So effective security architectures are typically multi-layer. There'll be security measures taken in as many places in the architecture as makes sense. There's no requirement that these different security measures be interoperable or even aware of one another. In fact, there is advantage when security technology is not necessarily all hooked up. You climb one wall and follow that wall to the keep, that's not a good thing. If you have to climb 3 walls, one after another, you're going to be kind of tired at the end. So from a security perspective, heterogeneity is not necessarily a bad thing. From a management perspective, if you want to drop that into the bucket, it's a much more complicated issue.
At IPSO, we have a working group on security, but it's dedicated to identity and privacy. And this came from liaison with OCF and IIC, because trying to delegate some of the work, because if everybody tries to do everything, then we're going to reinvent the wheels in multiple places. So right now, the large consortiums are trying to okay, you take care of this, I take care of that. So at IPSO, we have accepted to start working on the identity portion of security. So we have on the working group, we have Intel and ARM, both sitting at the same table, defining how can you define an immutable identity for a device. Then starting from that, then you can build, the chain, the root of trust, and et cetera, because the device has an immutable identity, can be tampered with, you can play with, can be, et cetera, et cetera. So these are things that are happening now. It's going to take time. It's going to take, and I think the last Gartner report also on this disillusions, the curve of technology adoption, say with IoT we're just beginning to be in the decline before we reach a plateau. So we're going to be depressed for the next 2-3 years because we're going to see this doesn't work, so we're going to get there, and we are in these stages in some of the definition of especially some of the security blocks, cost versus capabilities, feasibility. This is where we're going to, in the next 2-3 years. It's going to be tough.
But okay, but nevertheless, so still on the security, do we need to wait until a specific security standard emerges, which will say this is how we do security in IoT end to end, or we're just gonna go like cloud by cloud or whatever? Any installation by installation, how are we going to do that?
My answers to people who ask that question is that no, don't wait. If your ROI, if your return on investment calculation gives you a profit or a saving at the end, do it now. But there will be additional building blocks in the following years that will make your cost lower. So when you're going to design something, design it in a way so that you can improve, especially in an embedded device. Okay, I'm always going to take my hat from the embedded device point of view, build it with a processor that still has enough room for more code and room for more data space. So more flash, more RAM, because you'll need to add these additional blocks, these additional security blocks or provisioning blocks or whatever, okay? So design your product so that it can evolve. But if you have a positive ROI today, go. Don't wait, go.
In the case of OMA, we reuse security from other groups, ITF. And in the particular case of lightweight end-to-end, our transport is UDP, and we utilize DTLS. So we are not trying to reinvent anything. We look what is in the industry, and we adopt it wherever it's needed.
Right, but this is that's specifically transport. I'm talking more in terms of the overall umbrella, because there's a whole bunch of other things in the higher layers which go way beyond transport. Transport we can reasonably secure, unless Stacy will disagree, but for the higher layers it's going to be...
No, transport is something we can handle. What I'd say on that is there are a number of generalized standard security architectures that are relevant in the IoT space, such as ISA 99. Architectures like that don't specify technologies, they specify an architecture. There are also a large number of standard security technology elements, such as secure sockets layers, AES encryption, firewalls. So there's no reason to wait. These technologies and these architectures can be applied today. If there are unique and unusual features of a particular IoT deployment that create security attack surfaces that are themselves unusual, that will come out. We'll read it in the paper, and that should spur new action.
Okay, so like my takeaway from this would be that we got the security have to be properly architected, but we don't really need we got bits and pieces which we can use, but we don't need to...
Yes, and trial by fire will tell us what works and what doesn't.
Yep, I see. Yes?
Another question, so related to security, Christian mentioned privacy. Privacy is what hits the consumer press, but privacy is defined differently around the world in different social contexts. How can standards deal with privacy?
The problem I have with privacy is that it's not a technical question, it's a legal question. And there's no standard, I think, that can adopt it other than laws. Go ahead, Carl. Microphone.
There's an interesting effort going on in the W3C on basically associated trust. So you don't use security until you actually have a trust relationship with people. So while it's not directly privacy related, it basically makes it so that there's a zone of community that basically allows access. So it's kind of, I don't know, the positive to the privacy side, right? Of here's who I want to share with, as opposed to who everyone else is excluded.
And Christian, I'd say privacy is in fact a policy. So in fact, the standards would need a policy enforcement mechanism, not knowing what the policy is going to be, perhaps.
And maybe it will differ country by country. Yeah, that's
right, but they should have enablement for...
Yeah,
the technology is the building blocks, but how to use it, it's today. It's the same thing with IoT today. Your IoT is different than my IoT, but we're all using the same building blocks.
And with that?
With that, yes. And with that, thank you very much, our panel. I would like to give our panel a round of applause.
Thank you.
Thank you.
I think we I don't know, I'll let Carl to be the judge of it, but I think we took the dry subject of standards and we managed to entertain you at least a little bit. So, all right. Thank you very much.